Agile and Lean Concepts for Teaching and Learning. Part 1. Agile and Lean Concepts in Education. The chapters in this book are organized into a number of sections, beginning with chapters that provide various overviews of Agile and Lean approaches to education. There are also chapters that look at Agile methods in the school classroom, followed by a section of chapters that address ways of reconceptualizing learning environments using Agile and Lean approaches. The next section covers Agile and Lean learning processes and is followed by a section on using Agile and Lean methods to teach software development. In this chapter, look at how Agile and Lean ideas have been taken from industry and applied in the classroom. Then we take the key themes and concepts from both these approaches and integrate them into a simple conceptual framework that identifies the main ways in which these two industrial practices have been applied to teaching and learning, regardless of subject discipline and level of education. In doing so, we aim to draw out the important skills and practices that are required in making this transition from one domain to another. Agile methods. Agile methods for software development evolved as a response to the changing dynamics of the software industry in the 1990s. The focus on customer needs and being responsive to changes in requirements at any phase of development were seen as increasingly important. Although agility itself is not formally defined within the manifesto, its principles only refer occasionally to agile processes. The concept of welcoming change is embodied within these principles, along with collaboration, motivation, and reflection. Agility within software development is underpinned by these concepts to rapidly create, embrace, and learn from the change while contributing to perceived customer value. Next is Agile in Education. In a rapidly changing world, education also has a pressing need to do the same. The aspects of change, flexibility, and leanness, a concept borrowed from lean management, also introduced above, are just as important in education as for software development. Educators are constantly subjected to change as new and emerging techniques, tools, and ways of teaching are assessed and implemented to support the dynamics needs of today's learners. Mapping Agile methods to classroom practice. For example, Dewey and Munyandi 2014 draw together some literature on Agile approaches to teaching and learning, but their summary of techniques is very general. Example, small group discussion, problem-based learning, blended learning, cooperative learning, etc. And it is hard to link these practices specifically to any Agile sources. According to Obrist et al. 2011, examine how the adoption of Agile team rules, such as testers, informants, and design partners, within design-based activities can clarify and strengthen team participation. However, this discussion only focuses on one aspect of Agile, and again, the mapping between the specifics of Agile industry practice and what might be termed Agile teaching practice is at a somewhat abstract level. Reinterpreting Agile practice for teaching and learning. If we are to be able to make specific recommendations about how educators can use Agile practices in the classroom, then we have to break them down into implementable strategies. To do this, we analyze Agile teaching and learning at the level of values, processes, and techniques. Agile Values. 4 Agile values are expressed in a manifesto for Agile software development. His version states that we are uncovering better ways of educating children by doing it and helping others do it. Through this work, we have come to value individuals and interactions over process and tools, meaningful learning over the measurement of learning, stakeholder collaboration over constant negotiation, responding to change over following a plan. In addition to the 4 values, the Agile Manifesto also includes 12 principles. These can be seen as a set of competencies of individuals and teams that together enable Agile development. In reference to education, Zan and the rest of his members point out that these Agile competencies are not limited to technical skills, but also encompasses social skills. Both Agile values and attitudes and outline an Agile model based on learning through personal experience, social learning and learning through realistic discourse, and construction of values and value identity. Collaboration and communication are seen as key to these ideals. Making learning agile. Bringing these various ideas together, Agile education might focus on the ideas of an iterative, adaptive process of student-directed learning built around learning stories created by students themselves. Students would work mostly in pairs and self-organizing teams, providing each other with constant support, feedback, and mutual learning. Regular learning checks would take place through stand-ups and retrospectives, giving an opportunity for reflection on learning and embracing change where necessary. Students would be encouraged to develop broad skill sets and base their learning on real-world problems. Educators would act primarily as coaches, guiding learners after then directing them, and the constant emphasis would be meaningful learning above all other concerns. Lean manufacturing. Lean is an approach within manufacturing that has its roots in the Toyota production system from the second half of the 20th century. Lean production was conceptualized as a way to reduce waste, upskill workers, improve quality, and provide more variety in products than was possible with mass production. More recently, it has been applied to the development of software in what might be termed the post-Agile period. Since then, many people have been looking for ways of applying these lessons to their own work context by applying lean thinking, which addresses how the lean production ideas from the car industry can be applied to a range of other industries. Value, the value stream, and perfection. 3 of the original 5 lean principles outlined by the Lean Enterprise Institute are value, the value stream, and perfection, the others being pull and flow. Value is both the end product and the chain of processes that deliver it. The value stream is each step in the value process, designed to be as efficient as possible in meeting customer expectations, while perfection is pursued through continuous improvement. Agile education, lean learning. One of the key concepts from the values and supporting principles of the Manifesto for Agile Software Development is that Agile approaches give agency to both developers and customers. Giving students a similar sense of empowerment and agency over their own learning is an important challenge for 21st century approaches to teaching and learning. While developing the broad skills encouraged in multi-skilled Agile teams also reinforces learning agency. In Agile software development, the key measure of progress is working software, and creating this requires well-developed technical skills. In education, the key measure of progress is meaningful learning, and in the 21st century, this is primarily skills-based, not just technical skills, but broader capabilities such as adaptability, collaboration, knowledge, construction, real-world problem-solving. A review in Agile Methodologies in Education. Agile methodologies are open to changes in requirements and encourage constant feedback from end users or customers. In an Agile life cycle shown in Figure 1, there is not a strict sequence of events to follow as the classic waterfall model has. The phases are flexible and always evolving, and many of them can even happen in parallel. First, the requirement analysis. It involves many meetings with the managers, stakeholders, and users to identify the business requirements. The team collects quantifiable, relevant, and detailed information. Example, who will use the product and how. Second, planning. Once the idea becomes viable and feasible, the team splits it into smaller pieces of work, prioritizing and assigning them to different iterations. Third, design. The team looks for a solution for the requirements, together with a test strategy. Fourth, development. The features are implemented. Second to the last, testing. The produced code is tested against the requirements to make sure the software is solving the customer needs. And lastly, the deployment. At this point, the product is delivered to the customers to be used. But this is not the end of the project. It can only be a partial delivery, and new requirements could come. The following are some Agile methods. Adaptive Software Development or ASD. It focuses mainly on the problems in developing complex and large systems. The method strongly encourages incremental, iterative development with constant prototyping. Its aim is to provide a framework with enough guidance to prevent projects from falling into chaos, but not too much, which could suppress emergence and creativity. Crystal Methods. A family of methods for collocated teams of different sizes and criticality. Clear, yellow, orange, red, and blue. Crystal Clear, the most used one, focuses on communication in small teams developing software that is not life-critical. Clear development has 7 characteristics: frequent delivery, effective improvement, osmotic communication, personal safety, focus, easy access to expert users, and requirements for technical environment. Next is Dynamic Software Development Method or DSDM. It divides projects into 3 phases: pre-project, project life cycle, and post-project. 9 principles are present: user involvement, empowering the project team, frequent delivery, addressing current business needs, iterative and incremental development, allowing reversing changes, high-level scope being fixed before project starts, testing throughout the life cycle, and lastly, efficient and effective communication. Extreme Programming or XP. It focuses on best practices for development, the planning game, small releases, metaphor, simple design, testing, refactoring, pair programming, collective ownership, continuous integration, 40-hour work week, on-site customers, and lastly, coding standards. Feature-driven development or FDD. It combines model-driven and agile development with emphasis on the initial object model, a division of work in features, and an iterative design for each feature. FDD claims to be suitable for the development of critical systems. An iteration of a feature consists of 2 phases: design and development. Kanban. It is a scheduling method developed by Toyota for lean production. It was designed as a system for scheduling to facilitate the production and inventory control. Using Kanban, work teams can achieve a just-in-time or JIT manufacturing, reducing flow times within production system and response times from suppliers and to customers. Last, Scrum. It focuses on project management in situations where it is difficult to plan, with mechanisms for empirical process control. The feedback loops constitute the core element. The software is developed by a self-organizing team in increments called sprints, starting with planning and ending with the final review. Then, the product owner decides which backlog items should be developed in the next sprint. Team members coordinate their work in a daily stand-up meeting. One team member, the Scrum Master, is in charge of solving problems that might stop the team from work efficiently. Agile in Education. Table 2 shows the values defined in the Agile Manifesto and the applied mapping, which consists of the translation of software development figures and rules to the education environment. Table 3 shows the original principles of the Agile Manifesto and the mapping that Stewart et al. Applied to the context of the educational environment. In line with the values described above, the 12 principles highlight that the highest priority of Agile instructors is to satisfy the needs of the students, together with their families who become an active part in the learning process, through the early and continuous delivery of meaningful learning. Every change in this direction, even late in the learning cycle, is always welcome. Extreme Programming. XP is a development methodology that is intended to improve software quality and responsiveness to change in customer requirements. Figure 3 shows the XP life cycle. XP allows frequent releases in short development cycles, improving the productivity of the team, and at the end of which new customer requirements can be adopted. XP employs user stories and associates acceptance tests to them that need to be successfully passed before the stories can be considered as done. Moreover, the programmer is expected to write tests for the individual tasks that contribute to a story. Indeed, XP put tests before code, and each piece of code is expected to be associated with a test, or it should not be integrated. Scrum. Scrum is one of the most employed process frameworks implementing Agile values and principles. In Scrum, the software is developed by following an iterative model used to manage people and complex projects. Figure 4 shows the Scrum life cycle. It follows a set of roles, responsibilities, and meetings that never change. With Scrum, the products are built in a series of fixed-length iterations, short and on a regular cadence defined as sprints. During these intervals, teams have the time to develop the software, and at the end of each sprint, example, the milestone, the progress is tangible. By using short iterations, the importance of a good estimation and the fast feedback from tests are reinforced. Everyone in Scrum plays a specific role. Product owner serves as an interface between the development team and its customers. He or she is responsible for checking that the expectations in the form of a prioritized wish list called product backlog are respected. Scrum Master, a facilitator within the team members. He or she is responsible for ensuring that the Scrum best practices are respected and the project moves forward. Scrum Development Team comprehends the developers that work together to create and test incremental releases of the product. Scrum defines 4 events related to a sprint called ceremonies. Sprint planning. The team meets and determines what to complete in the coming sprint. Daily stand-up or daily scrum. A 15-minute short meeting for the team to sync on the project progress. Sprint demo. The team shows what has been produced during sprint. And lastly, sprint retrospective, a review. Practices of Agile educational environments. Analysis from the perspective of the public, private, and third sectors. There are 11 practices of Agile educational environments. First, inspire, don't lecture. Second, employ active learning or learning from experience. Third, link explaining to doing. Fourth, elicit reflection. Fifth, promote communication. Sixth, establish diverse teams. Seventh, assign roles to team members. Eighth, manage time. Ninth, foster awareness of abstraction levels. 10th, use metaphors and analogies, example other concept worlds. And lastly, emphasize the connections between the topic being taught and the larger context in which it operates. The HOT Analysis Framework. The HOT Analysis Framework is used for the analysis of Agile teaching practices in each sector. The HOT framework is based on 3 main perspectives. The human perspective deals with cognitive and social factors and relates to interpersonal processes, teammates, customers, management. The organizational perspective deals with managerial and cultural factors and relates to the workspace and to issues which are beyond the team's scope. And lastly, the technological perspective deals with practical and technical factors and relates to how to issues on a different level of abstraction. MERGE, or Management Education Research. The MERGE model draws on the concept of the meta-profession, namely, sets of skills that extend beyond a specific discipline or area of professional expertise, and that can be expressed meaningfully only after one has first gained disciplinary or professional knowledge. Mapping of the Agile teaching practices according to the HOT framework. As just suggested, the 3 meta-professions are management, education, and research. The management component includes skills such as time management on the individual and team level, teamwork, cooperation, communication with customers, and organizational culture. The education component includes skills related to learning, teaching, presentation, team learning, diversity, and many more. The research element includes understanding and using research models, data collection and analysis methods, and drawing reliable conclusions. The full merge model has three layers. The base or foundation is the individual's disciplinary knowledge. The second layer includes the three meta-professions. And the third layer, generation, involves integrating the first two layers so as to successfully perform one's professional or organizational role. Application of Agile teaching practices in the three sectors. First sector, school principal. The first public sector comprises governmental organizations and local authorities, as well as all organizations which are under their responsibility. This includes government offices, local services provided by local authorities and municipalities, and public schools and hospitals. Second sector, team leader. Private, for-profit organizations comprise the second sector. This sector includes banks, firms, shops, and private services, such as private health organizations, insurance companies, and all other for-profit businesses. Third sector, faculty member. The third sector comprises not-for-profit NGOs that supply services not provided by organizations belonging to the first two sectors. It includes charities, philanthropic bodies, and non-governmental organizations or NGOs. In addition, public universities belong to this sector, forswearing profit in order to secure their academic freedom. University faculty members are evaluated by three main criteria: research, teaching, and service. However, from their first day, faculty members are also required to manage people, including graduate students, lab engineers, and administrative staff. When faculty members are promoted to the role of a dean or other managerial position, they also manage other faculty members. Our practices. Example 1. Reflection-based process. Engaging in reflection-based process is a sub-practice of illicit reflection. The Agile approach calls for an iterative reflective process that involves all project stakeholders and that relates to each individual's personal role as well as group process. In academic institutions, reflection is part of teaching and research activities. Educators should also reflect on their teaching on a periodic basis, even or perhaps especially in academic institutions where faculty members' main role is to research and the teaching role may be neglected unintentionally. Aspects of the reflection-based process sub-practice include promotion of reflective process on both the individual and the team level. Next is the increasing awareness of transitions between levels of abstraction. And lastly, examining decision-making process on a regular basis. Second example, product owner role. The product owner role is a sub-practice of assigning roles to team members. The Agile approach distinguishes between a project manager and product owner, where the product owner is responsible for presenting the business perspective on the product to be developed. Example, what capabilities it should feature, and the project manager is in charge with delivering the product on time and at a high level of quality. Aspects of the product owner sub-practice include ensuring the product owners know their roles and tasks. These include ensuring that the minimum viable product is expressed in the plan as early as possible, providing feedback to the project team at the end of each iteration, keeping up to date with clients' needs, and ensuring that these needs are reflected correctly in the work plan. Ensuring that the project team are on board and understand the importance of committing to the product owner's plan. Third example, strategies to anchor change. Develop strategies to anchor change is a sub-practice derived from emphasize the connections between the topic being taught and the larger context. In the second sector, and particularly in technology firms, this might mean using a lean iterative process and developing the product in a way that will make it easy to incorporate changes in the future. Aspects of the strategies to anchor change sub-practice include awareness that change may be both expected and unexpected, the use of lean implementations and mechanisms that enable coping with unexpected changes, being prepared to advance in small steps and to use suitable test mechanisms, and simplification that is refactoring when complexity increases. Kaizen and Education. Defining Kaizen and Lean. According to the legendary Japanese efficiency expert Masaki Imai, Kaizen means improvement. Moreover, it means continuing improvement in personal life, home life, social life, and working life. This implies a holistic approach to pursue excellence, organizational and personal, whereby all people are engaged in improving the organization every day, in all areas. Improvement is therefore not only the responsibility of a few improvement specialists. Kaizen is driven by 7 principles to be discussed later, and these differ from the 5 Lean principles, as described by James Womack and Daniel Jones in Lean Thinking, in that the latter focus on the process only. The 5 Lean principles are: specify value, map the value stream, create flow, establish pull, pursue perfection. The Kaizen approach is holistic and a representation of the Toyota production system as introduced to the world outside of Japan by Misaki Imai in 1986. It also includes the development of the human element in every process. It also expands to the improvement of broader society. The Purpose of Kaizen. The purpose of Kaizen is to create a sustainable organizational culture of excellence, focused on creating value for the customer by everybody, everywhere in the organization through continuously solving problems and reducing waste, inefficiencies. Customer value must be quantified in terms of quality, cost, and delivery, or speed. Defining what change for the better is in education. Education will only improve if we know what to improve and why improvement is required. Senior leaders and subsequently all staff members must be able to clearly articulate our strategic objectives. The Kaizen approach is intertwined with developing this mission, vision, values, and strategy. It is not merely a few improvement initiatives. We might change structures, curricula, our teaching methods, technology, and training aids, but we might just do more harm than good. Not only could students suffer and have suffered, but also teachers, parents, academia, and establishments, with our future as a society at stake. Change for the better should always be synonymous with the customer value we are trying to create. Education primarily exists because there is a need by the student that should be met. Foundational principles of Kaizen. To practice Kaizen, a team must understand the foundational beliefs, principles, values, and habits, driving efficiency and effectiveness. The 7 Kaizen principles, according to Coimbra 2009, are: create customer value, eliminate waste, engage people, go to Jamba, manage visually, process and results, and pull and flow. Create customer value. An educational institute exists because it meets certain needs of a customer. In other words, creating products or services that the customer perceives as being of value. It is, however, important to pinpoint what the value is that the customer requires. Remove inefficiencies or waste. The Japanese refer to it as muda, not getting paid for an effort. It is consuming resources without adding any value or benefits to the end customer of the process. Muda cannot be identified and removed effectively if a clear understanding of what value is has not been predetermined. Otherwise, activities might be removed that are not wasteful, or time can be wasted on fixing processes that should exist in the first place. Eradicating muda becomes more obvious and effective once value has been clearly defined. Engage and develop people. Engaging people is underpinned by a deep-seated respect for people and society in general. The Toyota production system has been an outstanding example of an effective and efficient organization due to their balanced, holistic approach. People and process should equally and simultaneously become better. Imai, 1997, states that engaging people requires everybody, every day, everywhere, are doing Kaizen for the betterment of all. Focus on Gemba. The Gemba is the front line of the organization, where value is created for the customer, but also where Muda, Mura, and Muri persist, and where it must be eliminated with the active support of senior leaders. Leaders at all levels need to be strong, connected at all coalface of education. Leaders need to derive their decisions and strategic objectives by what is happening, where students and educators connect. The opposite of Kaizen management is managing through reports and endless meetings behind a comfortable desk and managing in the internet or in the cloud. Manage visually. Visual management is the word used in Kaizen to describe the management style. It makes information and activities visual so problem deviations from standards become obvious. Imai puts it as follows. This is visual management, making abnormalities visible to all employees, managers, supervisors, and workers, so that corrective action can be taken. It can even be added that abnormalities and problems can be made visible to students and other stakeholders as well to enable their participation in improvement activities. An indispensable form of visual management in 5S, Better Workplace Organization, it is based on 5 words starting with S: sort, set, shine, standardize, and sustain. Process and results. Excellent results in education are consistently achieved if the teaching, learning, and administrative supporting teaching process are stable and repeatable through standardization. According to Imai, stability must be achieved in 5 key areas in a process to improve results, referred to as the 5 M's: manual power, people, machine or materials, methods and measurement. And lastly, pull and flow. The ultimate objective of the Kaizen methodology is to make services, example information and people, and materials flow when the customer needs it. When they pull the information, knowledge, service, or material from the educator or education process. It is also known as just-in-time process. Delays in a process easily turn into more muda, as previously discussed. When flow is hindered, value for internal and external customers diminishes. Kaizen and education. Kaizen leadership. The Kaizen journey will be doomed to failure if Kaizen thinking and Kaizen habits are not developed first in senior leaders. This might take time, but it will prevent numerous inefficient and fake Kaizen activities in the medium term and failure to improve in the long run. Kaizen leadership is critical in initiating planning, leading, and sustaining better ways of working. Imai refers to the 2 functions of organizational leadership. First, ensure standards are maintained, and second, promote the enhancement of the current standards through structured problem solving by all employees. Although leaders are usually well qualified, their decisions can be serious harm to processes, people, the environment, and society. Emiliani says, while we may think of leadership as intelligent, thoughtful, and capable, it would be wise to recognize it as an error-prone activity whose quality is normally very poor. Without strong, ethical leadership, any organization will suffer. The role of Kaizen leadership is to support frontline staff, the educators working at the coalface of the education system. In a Kaizen organization, the staff does not serve the needs of leadership. Leadership serves and enables employees to ensure value is being delivered to the customer, especially the student. They encourage and coach the use of structured problem-solving techniques in a respectful manner. The expectation of leadership at Toyota is to effectively develop people so that performance results are constantly improving. Hence, their mantra, "We don't just build cars, we build people." Kaizen leadership must be expressed through leader-standard work, formalizing disciplined leadership activities. This standardization of the leader's responsibilities supports the development of the new Kaizen habits of senior leaders, middle management, and frontline leaders. Although there might be challenges and obstacles to implementing Kaizen in education, it can deliver results traditional management styles cannot achieve due to its holistic and respectful approach. However, it will require strong servant leadership, humility, and a willingness to explore, experiment, and learn about the proven field of Kaizen. Education should learn from the bountiful Kaizen experiences, failures, and successes. Knowledge and skills available, especially from other sectors. Scientific thinking should not only be applied to curriculum development and research, but also to the processes and people employed in creating value for students and other stakeholders. To enable the creation of a culture of excellence, everyone in an educational institution must understand and apply the 7 principles, beliefs, and values every day, everywhere. Developing and cascading a clear strategy and policies to all levels is a primary responsibility of senior leaders. It should focus on making processes easier, better, faster, and cheaper, in that sequence. Goals related to people development and their motivational levels should also be monitored alongside the growth aspirations of the institution. Kaizen is a culture of excellence, not individual acts of brilliance, or even the use of Kaizen methods to make education better. It is the continuous improvement of a holistic system based on the 7 Kaizen principles, beliefs, values, and behaviors made explicit through the Kaizen capabilities of leaders at all levels. Creating Kaizen lighthouses or of excellence can overcome resistance to change when supported by respectful, caring leaders. Educational excellence will occur when the concept of Kaizen is so deeply ingrained in the minds of both managers and workers that they often do not even realize that they are thinking Kaizen. Part 2 of the book is the Agile methods in the school classroom. Transforming education with eduScrum. From the motivation that education needs to change to meet the needs of 21st century society, this addresses the various ways that adapting Scrum processes to the classroom enables students to become more independent and self-directed in their learning. The world is changing very fast and we must adapt to this change. Unfortunately, the current educational system is obsolete. We are still teaching as we did in the age of industrialization, which used to make perfect sense but is no longer applicable. This creates a gap between the educational offer and the market requirements, as nowadays, we need to not only educate workers, but leaders and highly adaptive thinkers. 3 fundamentals underlying this change. 1. Less need to examine knowledge retention. Instead, more focus on developing the students' 21st century skills such as collaboration, communication, critical thinking, creativity, ICT skills, etc. 2. Changing demands of society. Knowing your weaknesses as well as your qualities becomes even more important as the time of the individual at the workplace is over, with increasing emphasis on teamwork and collaboration. Going beyond the teaching of the subject to help students develop as human beings and let them progress in their personal qualities. The teacher is no longer the source of knowledge. In eduScrum, the students are working together in teams in an active, effective, and efficient way and have more fun. This is achieved by giving the students ownership of their own learning process, but most important, trusting them. The students take responsibility for what they do, because they are given the freedom and the space they need. The effect is that students are more engaged, more productive, and their results are better. They discover who they are and what their abilities are. Going through, let us first define what is eduScrum. eduScrum is an edit of Scrum, a framework for an active, collaborative, co-creative education process. It allows students to make assignments according to a fixed rhythm. They plan their own activities and keep track of their own progress. The teacher determines the assignments, coaches, and gives advice. In eduScrum, we go from teacher-driven education to student-driven and student-organized education. The teacher determines the why and the what. The students determine the how. With eduScrum, the students own their own learning process. This results in intrinsic motivation, fun, personal growth, and better results. Learning is the key element. Effective and efficient learning, learning to cooperate better, learning to get to know oneself better, learning to be co-creative. Students work together in an energetic, targeted way. This way of working generates pleasure, power, and accountability. The work goes faster and the results are better. eduScrum students are stimulated to develop into valuable members of a team and develop a mindset that aims for constant improvement. They pass through a positive personal development. eduScrum is a groundbreaking way of education, where personalized learning has a very important role, like the 4 C's of learning and innovation skills. The first C is creativity and innovation. Next, critical thinking and problem solving. Third, communication. And lastly, collaboration. eduScrum gives students a free rein to take agency over their learning. One of the modifications made to Scrum was to add a definition of fun to the process, as well as a definition of doing instead of definition of done. This is because fun is an important motivator for students and is an essential part of improving learning. In the learning process, it is the same for students. eduScrum captures the importance of enjoying and placing value in the journey. In education, the teachers are using eduScrum to teach accountability, self-motivation, team collaboration, and proper time management skills to their students, using the work in the actual school curriculum as a vehicle. The secret of eduScrum is ownership. Students are given ownership of their own learning process, but most important, trust. The students take accountability for what they do because they are given the freedom and the space they need. The effect is that students are more engaged, more productive, and their results are better. The collaborative nature of eduScrum leads to personal development based on the 4 building blocks: trust, communication, involvement, and accountability. Cooperation requires mutual trust between students. In addition, communication is very important so that they learn to be themselves and dare to say what they think. These 2 building blocks provide involvement within the team, which in turn leads to accountability. The 4 building blocks refer not only to the team as a whole, but also to the individual students. An outline of eduScrum. Teams. In eduScrum, work is done in teams of 4 to 5 students. eduScrum teams are self-organized, which means that they themselves determine how they want to work together within the set boundaries of the assignment and framework. One of the first meetings in an eduScrum project is team formation. The team formation meeting takes place at the start of a sprint. First, a team captain is appointed by the teacher or chosen by the class. The team captain is not the boss, but someone who makes the team work well. Regardless of whether the team captains are chosen or designated, they choose the members of their team so that they can achieve an optimal team composition. They choose their teammates based on the qualities needed for a good project result. Lists of potential team members are anonymized, and only the gender of the relevant student is known. Female team captains first choose a male team member, and vice versa. The order in which team captains may choose is varied as much as possible. The students then choose a catchy name for their team and make their own arrangements for how the team will work. After the team formation, The planning meeting will start immediately. The teacher as product owner and servant leader to the student teams. The teacher determines what student teams have to learn within which period of time. They design the projects for the students' teams, set the learning goals, and tell the students how they want to measure how their work has been successful, but are also there for the student teams as a servant leader to assist the teams and answer questions when needed. When teachers want to work with eduScrum in their classrooms, they must first have trust in their students. Second, they need an open Agile mindset, giving students content-based assignments, or even better, projects where students themselves can determine what they want to learn and most importantly, how they want to learn. Then, the why. The why of learning will become normal, which fosters a lifelong learning process. Start with the why. The teacher decides the why and the what of the assignment, which is crucial for a successful eduScrum project. For every teacher who wants to get the full potential from his students, the golden circle can be the starting point. Framework and process. The eduScrum framework is built to support teams and teachers in collaborative learning. The basic eduScrum concept consists of one result, roles, meetings, artifacts, and some simple rules. Together, they form a balanced structure. Each part within the framework serves as a specific purpose and is essential for the use and success of eduScrum. In the eduScrum framework, all educational approaches come together in an organic way. Students are working in projects where they gain knowledge and skills by working for an extended period of time to investigate and respond to an authentic, engaging, and complex question or problem, actively exploring real-world problems and challenges and acquiring a deeper knowledge. This gives their work a greater purpose. Students must acquire content knowledge themselves, not through the less engaging method of direct instruction. Thus, students guide their own learning, add their own meaning and experiences, dig into the material, and actively engage with the content. eduScrum Sprint. At the heart of eduScrum is the sprint. Doing sprints in eduScrum means student teams work together in short cycles or sprints according to the plan Do, Check, Act or PDCA learning and improvement cycle. The sprint is the teacher-defined time frame within which a certain amount of work has to be done for a context concept-based project in which one or more learning objectives will be realized. In school education, sprints last no longer than approximately 2 months. Every sprint begins with the planning of the work to be done for the project and ends with a review of the learning and working results, as well as a retrospective on team performance and personal development. In the sprint, teams work together to achieve the goal set. Usually, a sprint is divided into sprint reviews after approximately 3 to 4 hours of work. Students have the space within the framework and goals set by the teacher to find their own way to deal with their work and adapt according to their insights. Planning meeting. The planning meeting takes place in the first lessons of an assignment project. These are very important lessons for the students and the teams. Here, they get an overview of what to expect in the coming period. It is the kick-off of the project, so everything should be ready at this point. The definition of ready is all the actions and steps that the teacher and the teams must have done before they can really start with the assignment or project. During planning, the team altogether plans the tasks to be dealt with during the next sprint. They make their own plan transparent on an eduScrum board flap and think about how to do the assignment. In addition, they ask the following questions. What exactly needs to be done? How work will this be for us? How do we divide the work? What tools do we need? Stories. Stories are a way to describe the products that this sprint should deliver. A story describes what and why it has to be done. The how is not part of the story because it is left to the team in the planning meeting to decide how they want to self-organize. During the planning meeting, the teams create these stories and think about why they are doing what they are and what they want to learn. Stories are the things that need to be done in a sprint, such as making assignments, experimenting, writing a report, or preparing a presentation which needs to be delivered. Students provide a rough overview of the task to be dealt with. Celebration criteria. The celebration criteria are defined by the teacher and explained at the beginning of each sprint. This is done to ensure the quality of what is learned. The team is responsible for adhering to the celebration area and defines its own tasks and measures to ensure that the celebration criteria are met. These are learning objectives, assessment lists, answer models, exam requirements, etc., and the teacher's requirements for a story. The teams put the celebration criteria on their flap next to their stories. Working agreements are definition of doing and fun. Students also make working agreements and write them in their definition of doing and their definition of fun. These are agreements about the qualities of their products and working together with a pleasure to meet the celebration criteria. Each team gathers their own working agreements and puts them on their flap. Stand-up. The stand-up is an event which takes place regularly at the beginning of each learning unit. It is important that every team member attends this meeting. During the stand-up, the following 3 questions are addressed by each team member to help the team synchronize. What have I done since the last stand-up? What will I do for my team during this lecture unit? Do I have any obstacles or impediments? Do I see any impediments for my team? Particular attention should be paid to possible obstacles and problems. However, there is no deeper discussion about solving problems during a stand-up. If one team member knows the solution to a problem another team member has, he or she can briefly state that, to solve the problem directly after the stand-up so that the other teammates can start working immediately. The team captain ensures that the stand-up is held regularly and can moderate it. However, the team itself is responsible for the performance. After a stand-up, the flop and run-up chart are immediately updated. Review. The review is a kind of feedback meeting. In the review, the teams show what they have done at the end of 3 to 4 working hours or classes. The team shows what it has learned in this short cycle sprint and receives direct feedback from the teacher. The type of the meeting is determined by the teacher and may vary from sprint to sprint. These reviews should help the team members to check the self-developed content. It is important to see if the tasks have been successfully done. Personal and team retrospective and reflection. At the end of a project, each team will do a retrospective on their achievement and discuss how to do things better in the next project. Students look at their personal contribution to the team and how the team functioned as a whole. Teammates can answer the following questions to give and get feedback. What went well? How can I improve myself? How can I help others improve? How can we become better as a team? What should we no longer do? What actions do we take in the next sprint to improve? The retrospective is also a good opportunity to adopt and improve the definition of doing and the definition of fun. A good retrospective is characterized by the fact that there is a coach who guides the team through the process. In addition, it is very important to actually develop measures that can be implemented directly in the next sprint. Team and personal development. As a teacher, you have an important role to play in monitoring the quality of work reflection. The quality of this reflection process is an important factor in the personal development of the team member and individual student. This personal reflection retrospective about personality enables teams to work together more and more. These are extremely important steps in the process of becoming better as a person and as a team. This will not only increase your eduScrum process, but grow yourself as a team player and as a person. The flop. The flop is a large sheet of paper. Each team creates its own flop. The flop gives an overview over the process. It makes it clear to everyone what teams have to do during the sprint. It shows what has been agreed on and whether the work is on schedule. The flop is a chronological representation of the work during a sprint. The top line of the flop determines the project, which team the flop belongs to, and which members the teams consist of. This task status varies from still to do or to do, is being worked on, busy, to finished or done. The flap must be updated regularly, so it always shows the current process of the team. Updates takes place during the stand-ups. To do, busy, and done. The tasks defined during the planning meeting move according to their status from still to do, working, to finished. To do. The to-do column summarizes all tasks for a sprint, what needs to be done together in the coming period. The small tasks make clear what needs to be done so that results can quickly be achieved. BC. Each team member chooses a task from the to-do column at their own request, but always in consultation with the team. He or she moves it to the BC column and starts working. Of course, work can be done together with other team members to achieve higher team performance. Teams need to be aware also of which items do they all have to know and work on. Done. A task will only be completed if it meets the three conditions. All team members must agree that the task is done. The result must meet the celebration criteria. The teacher can ask any team member questions about the outcome of the task, and the team member should then be able to answer correctly. To meet these conditions, each team member must keep the others informed about the results and help each other to really understand what has been done in the task. In addition to the process fields, to do, busy, or done, the flap comprises the following areas, some of which we have already described above: stories, celebration, criteria, definition of doing, definition of fun, run-up chart, impediments. Run-up chart. The run-up chart visualizes the learning progress of each team. It makes transparent to the team where it stands and whether it has to work faster or not. Each task has a number of points. Certain numbers are assigned to this task using planning poker. Impediments. Impediments mean obstacles. All the obstacles that the team is struggling with are put into the impediments field of the flap, where the team records everything that is preventing them from working efficiently. Faults and obstacles of all kinds are listed here. The main impediments are listed at the top. It is up to the team to remove impediments as quickly as possible, but the teacher can also possibly intervene. The pillars of eduScrum. Like Scrum, eduScrum is based on the three pillars: transparency, investigation, and adaptation. Transparency. The eduScrum framework is aimed at the transparency of information supporting the learning process. Transparency is needed to help the teams make the right decisions and thereby maximize the value of the result. Transparency is created in the teams and with the teacher. It also arises because it is clear who is responsible for which part of the result by using a flap where everyone can see what is going to happen, what has been done, and whether the team still has the desired velocity. In addition, it is clear to everyone what the requirements are for executing assignments. Investigation. eduScrum teams must regularly review their progress towards the learning objectives. These learning objectives are not only subject matter, but also related to the functioning of the team and their personal growth. Investigations are clearly and strictly defined. These meetings take place at different times and levels in the workflow or process. Adaptation. An adjustment occurs when a team or teacher determines that one or more aspects may fall outside the acceptable limits or that the result will be unacceptable. Then the planning or the work in progress will adjust it to minimize further deviations. However, adaptation also takes place in the team's own functioning. eduScrum principles and values. Like XP and the Manifesto for Agile Software Development, eduScrum defines both principles and values. The principles of eduScrum are transparency, investigation, adaptation, collaboration, reflection, visibility, and iteration. The eduScrum values supporting these principles are trust, freedom, commitment, autonomy, personal growth, focus, ownership, authenticity, critical thinking, and creativity. eduScrum combines the principles and values into value principles. Principles are fixed, while values are in developmental and evaluate. There can be no real eduScrum without following these values and principles. Trust. This is the first phase of team development. A team that meets for the first time mainly consists of individuals that are not yet aligned. Communication. If confidence has arisen and team members experience safety, teams can go to the next stage. It is communicated in a respectful way. In addition, each dares to give their opinion, and discussions are being held and opinions discussed. A team of trust can also create conflicts. It can be stormy, but it is done in a respectful way and with a common goal. If the mutual communication goes smoothly and every team member participates well, the team members get involved in the activities that the team develops. Commitment. Because all team members talk, ideas are exchanged and each team member can give their opinion and become involved. The group of individuals will behave as a team. Synergy, cohesion, and cooperation develop and they speak in their own language. The team members feel increasingly involved with the common assignments. This involvement creates an organic process in which they will take accountability. Accountability. Through trust, communication, and commitment, team members experience a sense of accountability. The result. The team is accountable for the success or otherwise of the joint end result. Challenges of eduScrum. As with any method, there can be problems with implementing eduScrum, but more often than not, these problems arise from the neglect of an element of the framework. The use of the complete eduScrum framework ensures that students get the best out of themselves and their team and helps teachers to create a safe atmosphere. Part 3 is about conceptualizing learning environments using Agile and Lean approaches. Lean and Agile higher education. Depth to grades, courses, and degree programs. Lean and Agile is a departure from plan-based education. As the table shows, it represents the differences and similarities of Lean and Agile. Lean. Key focus on reducing waste, associated with the cost leadership strategy, would strive to contain only what is necessary, example, focus on waste reduction and cost leadership. While Agile, the Agile states and emphasizes the ability to adapt quickly to changes. Differentiation strategy and Agile education in particular would cater especially to students for whom cost might be less of an issue but who might want to differentiate themselves from the pack and get an education adapted to their personal preferences. As for the similarities, both share a preference for lightweight, iterative, and incremental development, which require more heavyweight documentation. Both are not synonymous. Iterative and incremental aspects, letting students pursue their education in an emergent manner as opposed to the traditional plan-based education dominant today. Key differences from plan-based education. Under plan-based education are big and often fixed-size courses, rigid degree programs, forcing big decisions upfront by students, detailed specification of programs and courses upfront, hard to find starting degrees of less than 3 years duration, primarily thinking full-time study, then full-time work, one-size-fits-all instruction. On the other hand, for Lean and Agile education are smaller courses or creditable units, more flexible degrees allowing for iterative decisions by students, limited specification, delaying decisions until the time of learning. Lean, also offering shorter degrees, 1 year or less, encouraging students to interleave studies and work. Agile, offering instruction more personalized to the individual student. Pursuing the minimum viable competence. The Lean or Agile learner could spend a month in university developing some competence, and for the next month take a job where the competence is used in practice, then come back to university to learn some more, then another job for a little while. Just like a Lean startup seeks to identify the minimum viable product to launch in the market, the student, with the help of the university, might seek to identify the minimum viable competence that could lead to an interesting job. A consideration of minimum viable competence might also be relevant in more traditional degree programs where students do want to keep studying for 3 years or more. Experiential Learning, example via internships and summer jobs, can be important both for motivation and students' holistic learning beyond and between the separate courses in a degree program, as long as the job is relevant. Obstacles to Lean and Agile. Table 2 shows the challenges of Lean and Agile education. Lean Agile property. Agile, allowing students more flexibility and variability. Challenge for university, poor economy of scale, increased teaching workload, difficult resource planning, and for the students, class erodes. Next is a smaller creditable units. The challenge, more assessments, more grading. Next, students making their own choices. The challenge, risk of incoherent choices, example prioritizing fun and easiness rather than relevance. Lightweight design of courses and degree programs upfront. The challenge is, it has a limited question and answer selection of topics driven by buzzwords. And lastly, Lean, getting students quickly to jobs. The challenge, reduce university income with current funding models. IT as an enabler for Lean and Agile education. E-learning and crowdsourcing. Mitigation of challenges by IT. Another challenge is Agile increased workload for teachers is offering diversity. IT-enabled solution. E-learning and crowdsourcing. Next challenge is the increasing number of tests and grades with smaller courses. The IT-enabled solution are e-exams, automated grading, peer review. Next challenge is students struggling to make good choices. The IT-enabled solution are ontologies of learning outcomes and job competence needs, job marketplace, and learning analytics. Teachers struggling to make good choices for question and answer. The IT-enabled solution is same as above. And last challenge is Lean, funding models not promoting quick studies. Its IT-enabled solution is new funding models. The future of grades and grade transcripts. Another question, however, is if we need to keep on grading, whether it be done by humans or machines. If learning and assessment cycles become more fine-grained, it might suffice to do a pass or fail for each learning outcome. The difference between a stronger and weaker student would then not be the grades, but a stronger student achieving more and a higher level learning outcomes, where the weaker student achieves fewer or just lower level outcomes. Meaning that the traditional grade transcript disappears, to be replaced by a much longer list of precise learning outcomes achieved by a candidate. The advantage? What employer would want to read transcripts manually nowadays? Few, especially if they have hundreds of applicants to evaluate. They would like to analyze then automatically, comparing candidates back to back via software application to make a shortlist and spend manual evaluation time only with people on the shortlist, while less is more could be true for the information shown to the human decision maker on screen. More is more would apply to the underlying data on which the analysis is based. Ontologies of learning outcomes. To really facilitate knowledge sharing and back-to-back comparison of learning outcomes across universities, it would therefore be helpful to have an international agreed ontology of possible learning outcomes in various subject areas. Thus, an ontology might not only help employers evaluating and comparing candidates when hiring, but also help students. In what call the competency marketplace, students might be able to see what jobs fit their competency profiles, and if they do not qualify for any jobs yet, what competencies are they lacking? The Lean student who needs to get work quickly could look for the shortest viable path to a job. The Agile student may pursue competencies that are needed in many different jobs, to have a wider selection and be less vulnerable to change. If such an ambitious marketplace becomes a reality, enabling the possible matching of jobs and students, it is unlikely that students would make incoherent choices of subjects. Grades may become an anachronism in the modern world of artificial intelligence and big data analytics. Systems analyzing large amounts of raw data on the fly might give decision makers much more targeted information than static reports. Example, grade transcripts that have distilled this raw data according to one particular dimension decided by somebody else. Static reports are not agile because they follow a fixed format, thus are not adaptable to the changing information needs of decision makers. For the potential depth of courses, the point is that if students are allowed to be agile and choose learning outcomes on a fine-grained level, with strong students doing more learning outcomes in a semester, weaker students doing fewer, the border between one course and the subsequent one, or between one course and another parallel one, will be blurred. One possibility is that degree programs will have to become a lot more flexible than they tend to be today, with less rigid requirements for how much students have to learn on various subjects, and in what sequence, to allow for more student agility. Another possibility is that degree programs will gradually disappear, instead allowing each student to emerge with a personal degree of whatsoever size and topic mix that fits the job market or individual preferences. Again, universities could maintain degree programs as recommendations. This is a package of learning outcomes that we believe qualifies well for a certain set of current and future jobs, and this is what we think is the best base and order of achieving these learning outcomes. Leveraging Agile methodology to transform a university learning and teaching unit. LTUs described by Holt, Palmer, and Chalice 2011 as contributing to the growth of staff capabilities for teaching and learning development, innovation, and advancement, have been lauded for being at the leading edge of pedagogical practices enabling university teaching staff to develop learning experiences that leverage innovative design and technology, play significant roles in enabling universities to enact missions of delivering high-quality learning experiences for students and adapting to the accelerating pace of change facing universities today. Agile methodology projects within organizational culture. One of the principles that needs to be continuously reinforced for the successful coordination of Agile projects is the recognition that while for the central managing unit, the endeavor might seem like the highest organizational priority, stakeholders on the fringes might see the work as one of many competing demands on their time, energy, and resources. A project leader therefore met with him one-on-one to consult and collaborate on necessary decisions in the process. At the conclusion of the process, he provided feedback that flexibility to meet one-on-one when you couldn't make meetings was highly beneficial. There was clear evidence in following sprint reviews that voice had been heard and considered. Professional learning needs. Professional learning needs of LTU and other staff emerged as Agile projects progressed and tools were adopted. Members developed expertise in tools and processes, leading to the creation of support resources and the facilitation of hands-on workshops and coaching. These supports became organic and synergistic in that members of project teams who became experienced in particular components provided coaching to other teams when they reached the point that they needed this just-in-time skills, strategies, and resources. A website was created to host these materials to provide easy access and distribute resource management. Unexpected gains in staff self-confidence. One of the key emergent themes across the written feedback from development team members and stakeholders was gains in staff self-confidence. The boost that participation in Agile methodology provided to numerous staff members' self-concepts and transformed the work from a series of time-limited projects to a sustainable exercise in professional development. Another project leader explained that a learning experience for both staff and those who supervised them was self-trust. Within this flat hierarchy approach, letting go of control, or in other words, not micromanaging, was a key learning outcome for staff who were normally in supervisory roles, and furthermore, that this changed the overall work culture sustained beyond the end of the Agile projects. Implications for practice. These recommendations are informed by lessons learned and are intended for consideration in a variety of organizations or teams, irrespective of industry or discipline. Project initiation. A key component of this recommendation is to be clearly articulate the framework process. Co-develop a common understanding of the guiding principles and values and model agility and flexibility in your approach. Sprint 0 is to seek common agreement on a workflow management tool in which all user stories, tasks, and team collaboration will be hosted. Sprint 1 is to celebrate the achievements of your team and encourage and empower development team members to individually present their work in the sprint review meetings, rather than having the project leader present on their behalf. Project close, specifically the project retrospective. Prior to the meeting, ensure that all development team members and stakeholders are briefed on the purpose of the meeting. These recommendations are intended to provide food for thought when developing and implementing a bespoke Agile framework within a team or organization. By no means are these recommendations exhaustive, but rather have sought to provide some helpful hints when transforming an organizational culture and adopting an Agile framework.
So continuing the part 4, in summarizing this book, we have the Agile and Lean learning processes. So first, we will have the criterion-based grading, Agile goal setting and course, and completion or completion strategies. The constructivist learning theories propose that a learner constructs their own comprehension of the subject through their prior knowledge, which emphasizes that learning is an individual process that reflects the background of the learner, and it is essential to let the learner personalize the learning process by choosing learning materials according to personal preference. Let's take a look closer to the versatile needs of the students. So we will have an example. So in figure 1, the diversity of teaching group is illustrated. Students in Group A are majoring in some other field than computer science. Consequently, Student B or Group B consists of students who start with no prior programming experience. Then, for Group C, it consists of students that know the basic prior to the course. Thus, they cope even without special attention from the teacher and are most often neglected in large teaching groups. For practical arrangements, all the course material is available online. It is delivered using the A+ course platform. The material contains an ebook where all the theories is explained and embeds automatically assist course assignments with immediate feedback. In addition to this automated feedback, the students also received feedback from teaching assistants for selected assignments. This selected assignment tests the core ideas of the course, thus giving the students first-hand feedback on whether they have actually understood the problems at hand or if there is something to improve on and pay attention to the future. So at the end of the course, students take an electronic exam, which is like a skill demonstration where the student shows under control condition that he/she can complete a small course assignment independently. So the course design is learner-centered. The students work according to their personal weekly schedules, and the teaching assistants are available upon request in the multi-purpose classroom at least during peak times. This way of working requires a lot of self-discipline from our students. On the other hand, it is very flexible. Also highlight that working in their own schedule does not mean working alone. They are encouraged to work in pairs and also to discuss their problems both with the teaching assistants and in the lectures. For grading, courses are graded on a scale from 0, failed, to 5 as the best. The final grade is defined by the completed assignments. In the A+ course platform, there are over 120 assignments, which are divided into 4 categories. We have A for elementary, where the students mostly just repeat something that was exemplified in the materials. B for basic, which mainly concentrate on one new topic, but are more difficult than elementary assignments. And for C, it is applied. Typically, the student has to combine knowledge related to more than one topic. For D, as an advance, these assignments require the student to get familiar with materials outside the core content. Points are allocated to assignments in accordance to how laborious they are. The largest ones constitutes approximately 100 points and the smallest is 10 points. So every student has individual learning goals and learning paths. As already pointed out, the overarching learning goal of the course is that the student is able to implement small programs independently. However, in the spirit of the criterion reference grading, with such a diverse student group in question, the student's individual learning goals may vary greatly. In contrast to the traditional grading, here, the grade that the student receives does not describe how well the student can implement given tasks, but how widely he or she has covered the topics handled in the course. This way of implementing differentiation of learning paths allow us to pay special attention to the group which is often neglected simply because other student groups needs more attention. As no student in the course is supposed to complete all assignments available on the course platform, some of the advanced ones can be so difficult that they also challenge the students with previous programming experience. So going further, there are kinds of behavioral patterns can be detected among students in the Agile course setup. So the following are identified as the archetypes of students. So first we have the perfectionist, who set their goal high and do practically all the available assignments. Second, we have the opportunist, who set their goal high and did not do the optional or the easier assignments. And third, we have well performers. These are who set their goals too high but who still got a good grade at the end. Then we have dropouts by missing assignments. These students who after some point were not able to pass the course or get the desired grade and stop immediately after that. Fifth, we have dropouts by missing skills. These students who completed enough assignments and even participated in the exam multiple times without passing it. Next, we have dropouts by failing personal expectations. These students who gain enough points to pass the course but not enough to meet the requirements of the target grade fail the course because they did not show up in the exam. Then we have the goal-driven students will stop all their activities immediately after they have gained enough points to their target grade. Then, lastly, we have compensating students. These students have missed a significant numbers of assignments but who then end up compensating the missing points by doing more demanding assignments. So in this student-centered agile style of arranging the course, there are student feedbacks. So approximately 80% of students says that course implementation of agile style has reported they work mostly independently and over 10% more often independently than in the multi-purpose classroom. So according to the feedbacks, it is very effective to be able to work on one's own space. But of course, there was also negative feedback from students who did not like the approach of working independently, but most of the feedback was positive. Now, going to teaching and fostering reflection, reflective practice is to evaluate your own actions and the consequences to engage in a process of continuous learning and is therefore an essential ability for professional development. So in order to know what is a reflective practice, we will first define what is a reflection. So in the numerous educational literature, there are a lot of definitions for reflection. In accordance to Shikidi, he states that reflection is a method thinking in which we consider the relationship between our thoughts and our actions in a particular context. Moreover, Smith also defined reflection as what is in relation to what might or should be and includes feedback to reduce the gap. While man defines that reflection is a process of inner dialogue, and while Logran summarizes the situation by stating that for some reflection simply means thinking about something, whereas for others, it is a well-defined and crafted practice that carries very specific meaning and associated action. So in addition to this, Kolb's learning cycle ties the concrete experience in a specific context to conceptualize insights from reflective practice. The transformation is facilitated by reflecting on one's own experience to modify known concepts. However, applying Kolb's learning cycle will yield different results depending on who does it. Brockfield refers to this by using different lenses, where applying a new lens, new insights. For an educational setting, Brockfield defines 4 lenses to structure reflection for the teacher. So the first lens is the autobiographical lens, which is used to reflect from a personal point of view. The second lens is the student's perspective. The third lens is the teacher's peers. Finally, for the fourth lens, it represents relevant theory and proven practice. So the teacher uses different techniques for the students to fathom the knowledge and skills of the master. So there are 6 techniques that were identified. First, we have modeling. The master demonstrates explicitly how a task is done. Then we have coaching. So the master supervises the novice in carrying out a task. We have scaffolding. So the master sets up supportive structures to guide and help the student to experiment on their own. Then we have articulation. So the novice uses the terminology of the trade to express new insights, their reasoning, and formulate new challenges. For as to reflection, so the novice is given the opportunity to compare their own knowledge and skills in relation to those of the master. And lastly, we have exploration. So the novice is given the freedom to explore on his or her own without the interference of the master. This indicates that reflection needs to be explicitly fostered and engineered in order to be effective in practice. The same way also in learning. So in order to formulate the problem and to reflect and learn from it, from our experiences, so we will use some resources or data sources in order to create a reflective practice, and thus also for the teaching approach. So first, data should come out from the course evaluation. So the course evaluation conducted by the university is a tool to gauge the satisfaction of the students and identify issues with constructive alignment, workload, and cognitive demand. Then, another source is from the student report. So a further source of information were the reports the students wrote throughout the course. So there are 3 mandatory written hands-in. The students need to reflect on how they define their process. They need to give a report on their progress by halftime of the course, including how they refine the process. And they need to describe their overall process and lessons learned at the end of the course. Another resources is from the teacher notes. Whenever introduced a new teaching moment, we took extensive notes about the reaction of the students, whether or not we feel we achieve our objective, which questions students ask, if the time allotted was sufficient. So continuing to lean learning of risk in students' agile teams. A software project can face many risks throughout its life cycle, from construction to deployment and maintenance. So risk is defined as any potential situation or event that negatively affect the project success, and such failure can be multifaceted: integration difficulty, requirements dissatisfaction, lack of reuse, and so on. So how to mitigate risk? So risk management is about managing risk items that refer to some particular aspects of software development task, environment, or process, which if ignored, it will increase the likelihood of a project failure. Managing can be decomposed into risk identification, analysis, mitigation, and monitoring. So basically, those risks identified by the students are considered as weights. So within the analysis of the risk, there is a strong focus on eliminating the. So when risks were instrumented as an essential part of the project's deliverable, the students' Agile team managed the risk in a collaborative and lean manner. So the findings could guide the ongoing effort of applying the lean principles in Agile teaching, learning, and practice. So these allow to suggest specific lean principles for risk management in students' Agile teams. So for the work feature, it will include improving the risk management teaching and practice in undergraduate courses, incorporating industrial strength tools in teaching and learning risk management, and applying more lean principles in the context of Agile risk management. So going further to the part 5 of this book, we will know how Agile and Lean methods used to teach software development. So firsthand, we will know how lean learning is applied. So what is perspective on teaching? So looking to learner-centered design of computing education, it gives us 3 useful terms to describe 3 different types of learning experience. So first, we have transmission, which describes the classic lecture situation. Then we have the second perspective, which is apprenticeship, which we use to describe a learning experience focused on the development of skills rather than theoretical knowledge. Then for the third perspective is developmental, which describes a personalized learning experience without a set of curriculum. Based on the book, in modern software development projects, it typically strive to reduce batch size with the aim of decreasing cycle time, decreasing risk, and increasing the quality, which is the main goal of Lean. So one mechanism by which might do this would be employ a Kanban. So it is a Lean method that focuses on flow through a system. By using it, it can aim to maximize throughput and minimize cycle time. So one of the tools of a Kanban practitioner is to visualize the workflow. So in a software project, this is typically done with a physical or virtual card wall divided into columns for the different phases that each piece of work needs to go through. So reducing cycle time in order to give more guidance and earlier feedback, change from asking students to design a whole system to asking them to consider individual design choices in different situations and examine how implementing something one way or another would affect the future maintenance of the system. So it will cut off the time. Then we have peer coaching. So according to study, one change that made a big difference to both student learning and marking load was to encourage students to pair program, which has been shown to be highly effective in a classroom environment. Then third, we have automation. A key to reducing the burden of assessment and feedback has been add automation where possible. This ties back to the practices where automation is used to allow testing of software to be done quickly, repeatably, and reliably. So moreover, we have project-based courses. So team working is an essential component of any program and is a key skill that many employers look for when hiring graduates. So it focuses on teamwork and collaboration for the development. And we feel that the best way for students to learn is to experience practically in a project-based courses. So for sustainable pace, it aims to encourage students to do more work on the project, to encourage sustained iterative progress on project, to encourage project to build system that lets person X achieve Y rather than research projects, and to remove any deliverables that do not directly add to the project, which is the main purpose for a lean process. And we have customer relationship, which aim to deliver a particular piece of software rather than to conduct an investigation in a research area. So we have lecturing versus coaching. So having reduced the transmission of software engineering materials through lectures, we have just provide a recap lecture during the first week of term, reminding them the agile techniques they used in the previous project. So rather than having a further lecture, it will provide individual consulting time to all groups by holding office hours. Groups can book slots to get specific advice on any problems they are having, particularly around the areas of project management, evaluation, or other matters relevant to the project. So next, we have developing a spiral curriculum for teaching Agile. So the teaching of Agile project management skills in higher education is a well-established practice at both undergraduate and postgraduate levels, where students typically demonstrate their Agile understanding as part of a capstone project in contrast to our approach, which builds upon students' Agile understanding over several taught modules. Moreover, teaching Agile concepts by sprinting for a full semester using projects set by teaching staff, mixing theory and application throughout, whereas the majority of assessments are based on students generating a portfolio of examples of work which can be used to showcase their talents to future employers. The quality of portfolio entries is marked against criteria set by module leaders in accordance with university best practice. So developing spiral learning for teaching Agile. So in the approach of spiral learning or spiral curriculum, students are build up their understanding of a topic, in this case, Agile project management, by repeated exposure to the concepts, starting with the core concepts and building upon this foundation with more complex concepts to reinforce prior learning. So spiral learning can be further broken down into two types. It can be horizontal and vertical integration. So what is a horizontal integration? So horizontal integration works across modules delivered in a single semester. So a client-based project span these modules, so lecturers work in semester teams and collaborate to schedule and deliver teaching, coordinate and scope project while ensuring all learning outcomes are addressed. For vertical integration, so it represents integration across time. So a thematic teams such as the Agile development team collaborate and share experiences to ensure effective scaffolding across the program. So leading to Agile approaches for teaching and learning. So what are the key elements and rules in an Agile process? So agility is regarded as ability of an organization, a team, or a person to adapt and respond to changes in its operating environment to make profit. And by that, a self-organization is one of the key characteristics of an Agile team. So they are formed spontaneously to work on a task, are not part of a formal organizational structure and have shared purpose. Moreover, while keeping the focus on the team goals, individual team members make decisions of their own task, leading to have an agile team members. So first, we have the mentor. So the mentor guides and support the development and team members during initial setup and encourages self-organization practices during execution of the task. Then we have the coordinator. So the coordinator manages and coordinates expectation with the agile team members, whereas the translator translates the business language used by the customers to technical terms used by the team members. Then we have the promoter. So the promoter promotes the agile methodology with the customer. And lastly, we have the terminator. So the terminator facilitates the movement of unsuitable team members who do not conform to the agile development practices away from an agile team. So as a result, communication and knowledge sharing among the agile team members play a vital role in an agile process. The capability of a communication medium and the process that is used for communication are also critical to smoothly carry out activities associated with an agile project. Shared patterns of communications are evolved and coordinated behaviors are established among the agile team members as they progress and work together on the shared task. So lastly, the part of the book shows the agile and lean activities and games for the classroom. So in this video, it presents a practical approach to better understand agile methodologies and principles in an educational context. So the main agile principles is given along with the agile methodologies that can be taught and applied in the classroom at tertiary level. So apart from traditional activities such as homework, tests, assignments, and lectures, practical approaches have been incorporated into the curriculum to engage students in an active learning. The practical approaches of Agile and Lean aims to bridge the gap between theory and practices, presents detailed practical approaches with respect to different agile methodologies and practices in a single work. So it additionally demonstrates how students can better understand agile concept by adopting active learning and being engaged in team-based activities similar to working styles in the industry. So first, practical approaches is classroom activities, and we have another lab practical. So classroom activities main objective is to give students hands-on experience of the different agile concept, while lab practicals, the main objective is to initiate students to agile software tools. They then apply the concept learned from the classroom activities by using the tools to practice what they have learned. So these are the classroom activities. As student-centered classroom activities are brought together to explain the agile methodologies and principles in a tertiary educational context. So another approach is a lab activity. So a lab activities were designed to initiate students to agile software tools.